Can you propose a synthesis that takes you from propane to what? 1, 2, 3, propanol? If you can, great. If you can't, stay put. Because this is something, if you were sent in that they were tasked with taking propane and converting it to a litany list of molecules, one of which was this molecule right here. So let's use retrosynthetic analysis to figure out this synthetic roadmap. So we have the same amount of carbons, 3 here, 3 here. However, we just have an aldehyde functionality introduced. So let's work backwards. How can we create an aldehyde? Well, if we have a selectively mild oxidizing agent like PCC, pyridinium chlorochromate, we can oxidize a primary alcohol, like this right here, propanol. Well, how would we get propanol? Well, what if we had propene, like that? And we did anti-Markovnikov hydration. So BH3 in THF, so hydroboration and sodium hydroxide peroxide. There we go. That gets us our anti-Markovnikov alcohol. Now, how do we get our propene? Well, what if we had 2-bromopropane? We just did an elimination reaction. So you can choose any base you like. I'm going to get a little crazy here. Use tert butoxide and heat. That'll give us our elimination product. And then this is the final step to get to this 2-bromopropane. How do we do that? That's the easiest part, okay? And if you like this video so far, please hit that follow button. We use just a free radical allylic bromination, Br2 and light. That'll get us that right there. So these are the steps we need. We do free radical allylic bromination to get our 2-bromopropane. We use E2 conditions to create our propene. Then we use hydroboration to create the anti-Markovnikov alcohol, and we oxidize it with a weak oxidizing agent, or mild, so I'm sorry, not weak, to our aldehyde.